Hey guys, wanted to make a video here about the theory of hydraulics, or pretty much most of hydraulics is based off this theory here. I kind of just learning how to use the screen capture thing, so if it's really confusing, please let me know and I'll have to remake this video possibly. Otherwise, I hope it helps everybody. So like I said, we're going to talk about theory, and hydraulic theory is really not that crazy. Some of the other theories we're going to talk about in other sections are kind of confusing, but hydraulics is really like logical. It makes a lot of sense to me personally, and I've noticed a lot of my students kind of pick it up very quickly. So we're going to go ahead and just jump right into it. So first thing, let's talk about the guy who invented it, or what the name of the law is. It's Pascal's law. It was invented by a guy named Blaise Pascal. Got a pretty freaking cool name for being born in the 1623 or something like that. I still don't see people named like that except like Chuck Norris videos. But he only lived for about 39 years. He really didn't live that long. I guess back in those days he just didn't live that long. I'm going to go ahead and paraphrase or just kind of translate the law into something everybody can understand these days. So I'm just going to read it off. It's any pressure applied to a fluid inside a closed system will transmit that pressure equally in all directions throughout the fluid. So we're going to go ahead and just roll down here. I hope this doesn't confuse too many people. And we're going to talk about figure 1 right here. So I think we call it in the description a wine bottle with a cork in it. So we're going to pretend this wine bottle is full of hydraulic fluid, just so nobody gets mad. So the actual cork here is this gray object, and let's say that this wine bottle is full of oil. As we push that cork in, that oil is going to pressurize, and that pressure is going to go equally out. It doesn't matter the shape, it's going to go out in all directions equally. It doesn't matter at all, anything. It could be any odd shape. You can see those figure 8 glasses or whatever, or figure 8 bottles. They'll do the same exact thing. So let's say we're putting 5 pounds of pressure on this cork, and it's pushing into the bottle with 5 pounds of pressure. Now that means each one of these red arrows is signifying 5 pounds of force going out. It's equal, and it's directly equal with what's going into it. Okay, so if you put 5 pounds here, you're going to get 5 pounds coming out. If you put 10 pounds in, you're going to get 10 pounds pushing outwards in all directions. So let's go ahead and we're going to roll down a little bit more and talk about the next figure we got here. So like I said, it doesn't matter what the shape of the vessel or the vase is. So we got this guy down here who's a really odd shape, right? But we're going to see that it keeps the same pressure everywhere. So we got piston 1. So this would be our we'll go ahead and name this one piston 1 really quick. This one over here would be our cork. Our cork to our wine bottle, right? So let's say it's got an area of 1 square inch. This piston right here. Now we got piston 2 over here, and I'm going to go ahead and write piston. Come on, 2. Piston 2 over here, and this one's got a square. It's got 10 square inches of area. Ooh, 10 square inches of area. So if we go and we push down on this piston with 10 pounds, that means everywhere with this P on it. Trying to underline them. You can tell. Trying to underline them all with the P. It's going to have 10 pounds, and it's going to be equally pressing outwards on all sides. But all the sides won't move, but over here piston 2 will move up. So now this is the multiplication factor that we're going to talk about a little bit later on, but you're going to see that this is one square inch. Well, this one over here is 10 square inches. So it's going to be multiplied by 10. So if we have 10 pounds coming in, and it's going to be multiplied by 10 square inches, that means we're going to have 100 pounds of force going upwards on piston number 2. Now, you might think that this is like old tech or something like that. Well, it actually turns out this isn't. This is still used today. It's not. It's still used today. We're going to go ahead and roll down, and we're going to talk about a bottle jack. So a bottle jack is the exact replica of this. It's got a small piston over here, and I'm going to go try to underline it again. Small piston, big piston. Now, and we can pretend that this one is over here is, number 1. And this one's number 2. Or you can just call this one the actual pump, and this one would be your extension rod on your cylinder. So if you look at it really closely, the only real differences between these two things are there's a hydraulic tank, and I'm going to go and try to, and it's inside here. And that is a cylindrical tube that's actually going around that extension rod. And then right here, we've got some check valves. We're gonna talk a little bit more about check valves later on, but right now, to get the gist of it, it's just a one-way street. It only lets hydraulic pressure or hydraulic flow go in through one way and not the other way. And that's done with a spring and a ball and seat area, okay? And there's going to be a picture later on, but this class really isn't about check valves by any means. But those are the main differences. So let me go ahead and clear these off. So what happens is the oil is going to come out of the tank, and it's going to be gravity fed into this piston. So let me go ahead and try to draw that. It's going to go through this tube, up, and it's gravity fed into this piston. So the check valve is going to close, and then oil is going to exit out this tube and into here. Man, my computer's freaking out a little bit. So, and then there's going to be that mechanical vantage. So if you had 10 pounds of PSI coming out of this, and you got 10 pounds of PSI in here, it's going to multiply across this piston, whatever size it is, and it's going to go out. And that's pretty much the basic logic of hydraulics. You're going to see this everywhere, all over the place. Now, today, is there a more advanced way of doing that? Yeah, you could use a hydraulic pump. That's probably the main way. I don't think any actual hand jack is going to be done like this, but anything that's actually engine driven or motor driven in any way will be with a hydraulic pump. And then right down here we just have a little bit of a picture of our what the heck? It's not liking that. Of our check valve. So, and you can see that you got your spring in here, you got your ball, and you got your seat that it goes into. So hydraulic pressure comes in this way, and it's going to push this ball back, letting the oil flow through it, and then it won't let it go the opposite direction. So that's pretty much everything you're going to need to know about theory, and we're going to kind of keep revisiting this to kind of keep talking about it so you understand a little better. I'd like to take a second, though, and kind of throw in some troubleshooting stuff. I know you guys don't totally have like a great grasp of what hydraulics is yet, but I'm going to start just throwing in some troubleshooting to make you guys kind of, I don't know, get your mind working a little bit. So we got we're going to roll down a little bit further down on the page here, and we've got the same exact hydraulic bottle jack that we had. And this is the same, this is pretty much how any bottle jack is anywhere. This will be the back seat of your car. This is the bottle jack. They're all pretty much built the same way. So the problem I've written here is the extension rod won't go out. So pretty much this being the extension rod, what the heck? Extension rod, it will not go out. So what things could possibly be going wrong to make that bottle jack not extend? Well, we've got all this this oil in these reservoirs right here. Oops, man, that sucked. In these reservoirs over here, well, typically bottle jacks leak and they go everywhere, and they don't get used a lot. So I would make sure there's oil in it. Oil is kind of like the gas in your car. If you don't have gas in your car, it's not going to go. So first things first, check that oil. If you are low on oil, you're going to notice it kind of operating funny. It'll go up for a little while, then it'll stop, or it'll jack like half of a stroke, and then it'll go back down. it's kind of a weird phenomenon there. Another thing that could be happening is you can see this little black dot right here and right here, and I think you can kind of see them here on both sides of these, and they are the seals that seal the piston to the actual cylinder bore. If those pistons or those seals are worn out in any way, oil will just go right by them, and you'll never be able to build pressure. Could also be you've got a bad check valve right here, that the check valve's not letting the oil go through it. But in the reality is as you're troubleshooting stuff and you get a better understanding of how hydraulics work, there's only like 3 or 4 different things that could really be going wrong with it. So just trying to get your mind a little bit going there. If you got any questions on maybe some of the, just trying to understand it a little better, please come talk to me. Bottle jack is a great like image of the basic hydraulic system. So that concludes just our whole section on the theory of hydraulics. If you guys got any questions, please come talk to us. This is a really fun topic. Hope helped everybody. Thanks.